The next ones, we were talking about classifying systems of equations, and that basically you have three ways to draw two lines, because a system of equations means you're doing two lines. So here they have two lines where the slopes are the same, so my lines end up being parallel to each other. If my lines are parallel to each other, they are not going to touch, so they're not going to have anything in common. These ones are called inconsistent and will have no solution. So anytime I have parallel lines, we're going to say they're inconsistent and have no solution. The second way you can draw two lines is on the next page. I can have two lines that touch in a point, right?
Yep.
If I have two lines that touch in a point, the point where they intersect would be one of those points that you could plug in and get a yes and a yes. So these ones are going to be called consistent independent. Consistent means they have an answer. Independent means one answer. So your one answer is going to be a unique solution, and it's going to be the point where those two lines cross. So in my ordered pair, the x goes first and then the y, so I go over 1, up 3, so my solution is the point 1, 3. And I got to move my board up just a little bit because I'm cutting off the answer. So the next way to draw two lines, although it looks like it's only one line on your graph, it actually is one line right on top of the other line. So every single point on the first line is touching every single point on the second line. Those ones are called consistent dependent. And they're going to have infinite many solutions because every single point on line 1 matches up with every single point on line 2. And there's a whole ton of points on those lines. So they say, oh, there's a whole lot of solutions there. So that's what you're going to see. One of each kind, and you're just going to pick what kind it is and how many solutions you have. And if it is a unique solution, we're going to name what the solution is. So number 5. On that first one, what kind of system of equations is that?
That one is consistent independent.
Consistent independent, it's going to have?
It's going to have a unique solution.
A unique solution because it touches in one point, and that solution would be at what point?
Okay, we went. Is it going to be 0 and 3?
It is going to be 0, 3. We went over 0, up 3. So 0, 3 is our solution, exactly. Second one on number 5, my board would quit hopping all over the place, are the ones where you have two parallel lines. If you have two parallel lines, what kind of system is it?
Inconsistent.
Inconsistent, and what does it have for solutions?
No.
None, because those two lines are never ever going to touch each other if they're parallel. And the third kind there on number 5, on the top of the next page, are the ones where it looks like it's just one line, but it's really one line right on top of the other line.
So that's a consistent dependent.
Consistent dependent, and has
Infinitely many solutions.
and infinitely many solutions. A whole lot of solutions. Every point on either line works. And number 6, we're going to do it one more time here.
That one is going to be a consistent independent.
Consistent independent, because it touches in a point
It's going to have a unique solution.
and has a unique solution, and that solution is?
Is going to be 3 and negative 1.
Exactly, 3, negative 1. My board would quit hopping everywhere. I could keep track of where I was. So, the second one on number 6 is on the top of the next page there. What do we got with that one?
We got a consistent dependent.
Consistent dependent?
And it has many solutions.
Infinitely many solutions, right. One line right on top of the other one.
And that one is going to be Inconsistent?
And the third one on number 6 is those parallel lines, which is inconsistent and has
And it has no solution.
no solutions because those two lines are never going to touch each other. Exactly.